let's start.
Oh, okay. So good afternoon, everyone. My name is Yang Junwei, majoring in information technology at Rensselaer University. And today I would like to present our article about comparison of forecasting models for banking stock. Okay, so firstly, I would like to introduce the background of our article. So regarding the rapid growth of the world commodity trade, the influence of the stock market's performance has become an important factor on national economic. Therefore, the investment in stock attracts a lot of attention from the investors. All right, so using the appropriate models, forecasting models will help those investors to make accurate decision in the stock. So in our paper, we would like to talk about two main forecasting models. The first one is multiply linear regression, and the next one is artificial neural network. Okay, so before we start the statistical data analysis, we should make a data visualization because it will allow us to have a better observation in our data. So here, our research subject is from banking of stock in Bangkok Bank. Why we choose this to be our research object? Because Bangkok Bank is the first member of the stock exchange in Thailand, and also it is one of the leading securities companies in Thailand. So the data from Bangkok Bank will be more reliable. So here in this table, it shows like 6 variables. So, but 5 of them are the inputs or predictors in our model, and our output will be the BBL stock of Bangkok Bank. All right, so from this table, it shows the relationship between BBL to other variables, which is the output, the relationship between output to the input. Okay, so we can see the largest positive correlation is between SCT to BBL, which is 0.912. And also we have two negative correlation between GOL, USD, and BBL, and the other 2 million positive correlations between DJI and WTI and BBL. All right, so this is our data visualization. We find out the predictor and the output. Okay, so the next one is So the next one is our after we have the data visualization, then we can formulate our data models. Sorry. So here the BLB, which is the closing stock price, is the response variable in our model, and we'll list the other 5 variables will be the predictors. And we also classified the data set into 2 groups, which is training and testing groups is 70% to 30%. Okay, so after we have those models, we have to evaluate which one is better and suitable for the forecasting. So what we're going to do is to use the root mean square error to indicate which one is better. So well, obviously, like the better model will have the smaller IMC value. All right, so the next, this is the formulas of our models. Okay, so the first one is MAR model, which we're going to talk now. So you can see there are 3 correlations and the 3 are square. So what is difference is because it's like those 3 models have 3 different predictors. However, the R square, the correlation is similar among those 3 models. But actually the best model among those 3 is the last one with 3 predictors. Because as I just mentioned, we have to look at the RMC value, right? So the RMC value in the last model is the lowest one, which means that model will be the better one among those 3. Okay, so this the last one is our MAR model. The next one I'm going to talk about the AM model. All right, so in the AM model, we're also using the same predictors as the last model. But the AM models have three inputs, including SET, GOL, DJI, same with the last one. Okay, and because of this is artificial neural network, the sigma function is said to be the activation function for hidden and output layers, and also it have like three neural nodes in the model. Okay, so but regarding the data visualization, we find out like there are five variables, right? But in our MAR model, we only use three because the last one, it didn't have a significant large influence in the result. So we didn't use it. But in our AM model, in order to improve this model, we plan to add those two variables into the model. Okay, so you can say we have the first one only have three variables, and the other one has five variables. Okay, so this figure shows three inputs, which is three predictors, and this one has like five predictors. Okay, so after we formulate our model, and we can collect the RMC value of the all models. So you can say actually AM model is always better than MAR model in all the cases. Okay, but as I just mentioned, because we would like to improve our AM model here, so we decided to add two more variables in the model. So finally, we got the result is 0.03874. This is RMC value for the AM model with five predictors. And also this is the lowest value in the all models. So finally, we find out the best, or you can say the suitable one for forecasting stock. So yeah, so this is our presentation. Thank you for your attention. So any questions?
Thank you, Mr. Yang. Please turn on, Dr. Nongnut, turn on your microphone, please.
Okay. Hopefully you can hear me clearly. I'm going to switch on the camera as well. Okay. I have seen your presentations and also papers, and I have lots of questions. It's actually a good paper, and thank you for the presentation. It's very good. I have four main questions. Okay, I'm going to go through one by one. The first one is about the unit of currency that you use for the variables. You see, you have many variables, but some variables is US dollar, and some variable have Thai baht as a currency unit. Do you think this difference of the currencies could affect your result?
Well, I think it will have like influence. Maybe if I use like Thai baht, the result will be changed. But anyway, this is difficult in the deep learning and machine learning, you know, like because of the data difference, so the result will be different.
And the variables you use, you did not transform the variable into the change in, say, the change in gold price, the change in oil price, right? You just use gold price.
Yeah.
Okay. I would suggest you to transform the data first to avoid this problem. Because if you use different currency unit and plug it in MMR or NNN, even though it gives you some result and report you very low load mean square error, but interpretations of the model will be useless.
Okay, thank you.
The second point, why did you choose the load mean square error?
Well, because like regarding the things I have studied so far, this is a basic formula to say like which one is more accurate to find out the result. That's why I use the R square. But I believe there are other ways to do it, but haven't tried yet. Yeah.
Yeah, normally when we use the machine learning, deep learning, or even AND, yeah, we tend to measure the performance of the model using the forecasting measurements or the others measurements like what you are using. But I'm trying to say that there are many types of measurements that probably perform better and more consistent than the root mean square error. So I would suggest you to look at those and see when you use different measurements whether they affect the result or not.
Thank you.
Another point is I see your slides have the R square instead of the adjusted R square. When you compare the net, we call it as the net model. The net model is like you use the same independent variables in different regressions. You have one independent variable in the first one, and then two variables in the second one. But the first variable, the variable in the first regression is also in the second regression. Okay, this netting model, this kind of regressions, you probably have to use the measurement, the goodness of it, that take into account the increase in the number of independent variables. For example, like adjusted R square, AIC, SIC, this information criteria will take into account the change in the number of variable. You see, when you put more variable, you have higher R square. Yeah. So in this case, when you report the root mean square error or the R square, you will see very minimal difference across the models.
Yeah.
And there will be a question, did you take into account the other factor that could impact these measurements? Okay, but if you use, say for example, if you use adjusted R square instead of R square, the adjusted R square take into account the increase in the value in the number of variables. Yeah, so you can compare like 1 to 1, and there will be no questions whether the change of the adjusted R square is significant or not, or the difference in the root mean square error you report like 0.041 something. Yeah, and another one when you add two more variable, you have 0.040, which is very minimal difference, isn't it? So avoid using the measurement that's not taken into account this factor. Okay, that could be good for your paper.
Okay, thank you.
That's all for me.
Okay, thank you very much.
Maybe